More than 4 decades ago, NASA launched a spacecraft that was never expected to become one of humanity's greatest explorers. Built with technology that now seems primitive, Voyager 2 carried only a small computer, limited memory, and a mission focused on visiting the giant planets of our solar system. Its journey began in 1977, during a rare planetary alignment that allowed one spacecraft to travel from world to world using the gravity of each planet as a slingshot. The original goal sounded ambitious enough: explore Jupiter, Saturn, Uranus, and Neptune before drifting silently into space. But Voyager 2 achieved far more than anyone imagined. Its first destination was Jupiter, where the spacecraft revealed a world unlike anything scientists had expected. Massive storms raged across the planet's atmosphere, lightning flashed through towering clouds, and volcanic eruptions were discovered on the moon Io. These observations completely changed our understanding of the largest planet in the solar system. The adventure continued at Saturn. Voyager 2 captured breathtaking details of Saturn's rings and studied several icy moons in remarkable detail. The mission showed that these distant worlds were far more active and complex than earlier observations had suggested. Then came Uranus. Before Voyager 2 arrived, humanity had never seen this strange ice giant up close. The spacecraft revealed a planet rotating on its side, with an unusual magnetic field and a collection of fascinating moons. It was unlike any other planet we had explored. Finally, in 1989, Voyager 2 reached Neptune. Scientists expected a quiet, frozen world. Instead, they found powerful storms, extremely fast winds, and a surprisingly dynamic atmosphere. Neptune became the final planet ever visited by Voyager 2, completing what remains one of the greatest planetary exploration missions in history. Most spacecraft would have ended their missions there. Voyager 2 did not. After leaving Neptune behind, it continued traveling farther from the Sun, entering a region where no human-made object had ever collected direct measurements. Scientists knew that somewhere ahead lay the heliopause, the outer boundary where the solar wind from the Sun meets the interstellar medium. For decades, researchers believed this transition would be gradual, almost impossible to define. The data told a different story. As Voyager 2 approached the boundary, its instruments recorded dramatic changes. The flow of charged particles weakened, cosmic rays became more intense, and the surrounding plasma behaved differently than it had inside the solar system. In November 2018, Voyager 2 officially crossed the heliopause, becoming only the second spacecraft after Voyager 1 to enter interstellar space. This was a historic milestone. For the first time, scientists could directly compare the environment inside the Sun's protective bubble with the space beyond it. The measurements revealed that the heliosphere acts like a giant shield, helping protect the planets from a significant portion of high-energy particles arriving from the galaxy. Beyond that protective boundary, the environment became harsher. Radiation levels increased. Particle populations changed. Magnetic conditions shifted. Instead of empty space, Voyager found an active environment filled with invisible structures and energetic particles moving through the galaxy. One surprising discovery was that the heliosphere is not fixed. As the Sun passes through its approximately 11-year activity cycle, the heliosphere expands and contracts. Solar storms can push its boundary outward, while quieter periods allow it to shrink. This means the very edge of our solar system is constantly changing. Voyager 2 crossed during a relatively quiet period of solar activity, giving scientists valuable information about the structure of this enormous protective bubble. What began as a planetary mission had become humanity's first detailed exploration of the space between the stars. And the greatest discoveries were still ahead. After crossing the heliopause, Voyager 2 entered an environment that scientists had never directly sampled before. Interstellar space is often imagined as an empty vacuum, but Voyager has shown that reality is far more complicated. The spacecraft continues measuring plasma, magnetic fields, and energetic particles as it travels farther from our solar system. These observations reveal that the interstellar medium is structured and constantly changing rather than perfectly uniform. One particularly interesting result involves magnetic fields. Before the crossing, many scientists expected the magnetic field beyond the heliopause to point in a dramatically different direction from the one inside the heliosphere. Instead, Voyager 2 detected a surprisingly smooth transition, suggesting that the magnetic fields on either side of the boundary are more closely aligned than many models had predicted. Researchers are still working to understand why. Voyager has also detected plasma waves moving through interstellar space. These waves cannot be heard directly, but scientists can convert their frequencies into audio. The resulting sounds are eerie and haunting, offering a unique way to study the density and structure of the gas between the stars. These measurements tell astronomers that interstellar space is not silent or inactive. It contains magnetic fields, charged particles, shock waves, and clouds of gas shaped by ancient stellar explosions and the motion of nearby stars. In recent years, Voyager 2 has occasionally experienced communication interruptions and technical challenges. Given that the spacecraft has operated for nearly 5 decades, these events are remarkable but not unexpected. Engineers have successfully restored communications after several anomalies, allowing Voyager to continue sending scientific data back to Earth. Every signal now takes well over 19 hours to reach Earth, traveling across billions of kilometers at the speed of light. Because electrical power continues to decrease as its radioactive power source slowly weakens, NASA is carefully turning off scientific instruments one at a time to extend the mission for as many years as possible. Each remaining watt of electricity is precious. Attached to Voyager 2 is one of the most inspiring objects ever launched into space, the Golden Record. This gold-plated disc carries greetings in dozens of languages, music from around the world, natural sounds from Earth, photographs, and basic scientific information about humanity. It was never intended as a realistic message to extraterrestrials. Instead, it serves as a time capsule representing our civilization and our desire to explore. Long after Voyager's instruments fall silent, the spacecraft will continue drifting through the Milky Way for millions of years. It may never be found. Or perhaps, in some unimaginably distant future, another civilization could discover this tiny ambassador from Earth. Either possibility captures the imagination. Voyager 2 reminds us that exploration is not defined by perfect technology but by curiosity and determination. A spacecraft designed in the 1970s has become one of humanity's greatest scientific achievements, transforming our understanding of the outer planets, revealing the true nature of the heliosphere, and opening the first direct window into interstellar space. Its mission is gradually approaching its final chapter. But its journey will continue long after its last transmission fades into silence. Somewhere in the darkness between the stars, Voyager 2 will keep traveling, carrying a small record of humanity, and a reminder that every great discovery begins with the courage to venture beyond the known.